In this example, we are going to take a look at the three conditions for continuity by means of the graph of a function. All right, so here we have the graph of a function. You can see it's pretty convoluted. It has a lot of parts and things like that to it. The question that we want to answer here is f continuous at 3? So what we would do is to go through the three conditions. So the very first condition for continuity, right, is that the function is defined at 3. So in other words, I need to be able to find the point on the graph right here at which corresponding to 3. So here's 3 on the x-axis, so I'm looking for the point, and right here I see an open dot, right, which indicates that there's not a point on the graph where that open dot is, and I can't really find any filled dots or any values here. And so right away this function will not be continuous at 3, and the reason why is because it fails condition 1. I can't even get a function value at that point. So the conclusion here is that condition 1 is not satisfied at 3. There was no value there. F of 3 does not exist, right? And so that was condition 1 that needed to be met for continuity. So our conclusion right away here is that f is not continuous at 3. It fails condition 1. All right, next question is f continuous at 0? All right, so f of 0, we need to run through the three conditions to check, right? So f of 0, here we can see we have an open dot, but here we have a filled dot, and so condition 1 is met. F of 0 is equal to 1, right, on this particular problem here. So condition 1 is okay. Next, since condition 1 worked fine, we would check condition 2. Condition 2 is, does the two-sided limit exist? So if I look here, coming in from the right, I can see that the limit would be -3, right? And coming in from the left, the limit from the left would also be equal to -3, right? So the two-sided limit as x goes to 0 of this function would be -3. So condition 2 is met. The two-sided limit does exist at 0 here. But when I go to check condition 3, right, that is the function value equal to the two-sided limit? And the answer to that is no. So condition 3 is not met. The two-sided limit is -3, but that does not agree with where the function value is. It's a 1 here. So our conclusion on this one would be, hey, condition 1 is satisfied. F of 0 is equal to 1. Condition 2 was satisfied. The limit as x goes to 0 of f of x is equal to -3. But condition 3 is not satisfied. The thing that we got for when we checked condition 1 was not equal to the thing that we got, the number that we got when we checked condition 2. So our conclusion is that f is not continuous at 0 because condition 3 failed. Okay. Next question is f continuous at -3? So once again, we would check the three conditions, right? So what is the function value at -3? And we can see right here, here's where the filled dot is. It's at height 1, right? So f of -3 is equal to 1. So condition 1 is met. The function is defined at -3. Right. Next up, we would check the two-sided limit. Here we can see that the limit from the right, if we come in from the right, the function values are headed towards where that open dot is, and that open dot has a y value of 2, right? So the limit as x goes to -3 from the right is +2. And then we can see over here the limit as x goes to -3 from the left. If we trace this along right here, right, we would the function values are getting closer and closer to this the y value of this point right here, which has a y value of -2. So the limit from the right was +2. The limit from the left was -2. What does that mean for the two-sided limit? Well, it means that the two-sided limit does not exist. Okay, so right away, condition 2 does not work for this function. So the function is not continuous at -3. So here's our conclusions. F of -3 was equal to 1, so that was good. Condition 1 was satisfied. Condition 2, though, the limit as x goes to -3 of f of x did not exist. So as soon as we got that, our conclusion was f is not continuous at -3. All right, and now we're going to check this. The question is f continuous at -4? So here's -4, right? For our next value, we can see that the function value would be right down here at -3. So condition 1 is met. The two-sided limit as x goes to -4, if I come from the right, I'm going to here, which is -3. If I'm coming from the left, I'm headed to that same point, which is -3. So the two-sided limit exists and is equal to -3. Okay. And so the third condition, right, was that the function value, in this case -3, is equal to the two-sided limit, which is also -3. So condition 3 is met here for this point at -4. So our conclusions here, right, condition 1 is satisfied. F of -4 is -3. Condition 2 is satisfied. The limit as x goes to -4 of f of x is -3. And finally, condition 3, are those two values equal to each other? Yep, they sure are, right? They're both equal to -3. So that means condition 1 is satisfied. Okay, and so therefore all three conditions are satisfied, are true, right? And so our conclusion is that f is continuous at -4. All right, so that's a graphical look at continuity. Again, we're just working through the three conditions here, and hopefully you kind of see the situation, the intuitive idea of what continuity is. Here at 3, it wasn't continuous. There's a little hole or break in the graph right here. So so if I were sort of drawing this across here, there's a break or a place where I would have to pick up my pencil if I were drawing this across, because there's a little hole in the graph right here. If I were drawing across here at 0, right, again, to draw this graph, I would have to pick up my pencil here. There's kind of a hole or break in the graph like that, saying, remember, it wasn't continuous at 0. Right here along the x-axis, it's not continuous. Then sorry about that. And over here at -3, we had it wasn't continuous also, and I can see there's a big break or gap right in that function here. Okay, but at -4, where we found that it was continuous, we can just go straight across here, right? It's nice and continuous across here. We don't have, if we were drawing the graph here, we wouldn't have to pick up our pencil across that. We could just keep drawing it right down through here like that. Okay, so that's sort of the idea of continuous, and the word continuous kind of implies that, right? But here really, and for the problems that we're going to look at, it's really just a matter of checking the three conditions.